was, you know, it was good.
All right, guys, today we're gonna talk about ratio and function tables. So ratio table and function table is the same thing. Function is the fancier word on what we're gonna kind of get into later this year. So we're gonna graph a function table, we're gonna use it to answer questions, and we're gonna make sure we're able to like read a graph and know what the unit rate is. And again, looking at either the function table or the graph to figure out what that unit rate is. Unit rate, so it is connected. All right, so let's look at this first example here. There are 24 kids in every classroom. Fill in the function table. Okay, so obviously we would be graphing the ordered pairs, but we're not doing that because of you guys don't have graph paper or whatever. So here you go. There are 24 kids in every classroom. So I would have one, because you would have to have your number of classrooms, or number of kids, right? So if I have one classroom, for one classroom I have 24 kids. So 2 classrooms, I would then have 48. 3 classrooms, I would have 72, and so on and so forth. So let's just have 3. Do 3 of them. If I have no classrooms, I have no kids. Okay. If I were to graph the ordered pairs, your ordered pairs you would be graphing as 1, 24, 2, 48, 3, 72. This is your X, this is your Y. This is your X, this is your Y. Okay. So if I was to graph this, we could figure out the actual answer here. So if I continue on, going in the pattern, from 1 to 24, 4 to 28, or 2 to 48, 3 to 72, how am I going from my X to get to my Y? Well, you basically, 24 kids for every classroom, you are multiplying by 24. Going across, not up or down, across. You always go across. What's the relationship between your X and your Y? By the way, this is an equation. You could change it to this. Okay? It's an equation. So, following the pattern, how many kids are there in 12 classrooms? Well, if 12 classrooms is my X, right? Number of classrooms is my X. I would then have to multiply by 24 to get my answer here. So if I have 12 classrooms, I want to know what the heck the answer would be. So all you have to do here is 24 times 12. Okay, that would be 8, 4 out of 0, 4, 2. I would have 288 kids in 12 classrooms. That sounds reasonable. Okay, now, of course, I have to switch it out. Thinking about going in the opposite direction, now I tell you, hey, we have 360 kids. How many classrooms would that be? Well, I'm telling you, I have 360 kids. I now want to know how many classrooms I have. So if going forward is multiplying by 12, you would then do the inverse operation, which is, in this case, we're going to divide by 12. You're doing the inverse. You're going the other way. So the inverse of multiplication is division. The inverse of addition is subtraction, and vice versa. So if I have 360 kids, I want to know how many classrooms I have. So I'm going to take 360 divided by 12. Hopefully you can do that mentally. That would be 3 and then a 0. I would have 30 classrooms. And again, that should make sense because if you plug it back in, 30 times 12 is 360. So that works. You're using the inverse to go from your Y back to your X. Those are called inverse operations. Okay, same concept here. Each movie ticket costs $9.50. Fill in the function table. So we're talking about tickets, number of tickets, and I can't spell today, tickets and the cost. This is your X, this is your Y. So one movie ticket is $9.50. So what if I bought 2 or 3? I'm only gonna go up to 3, so same idea here. So 2 would be double that, right? So it would be $19, or you could put .00 if you really want to go fancy. And then I do another $9.50, so 3 times $9.50 is $28.50. Let's see, 19 plus $9.50. Yep, $28.50. Okay. Now, I did it going by adding $9.50. However, how are we going in this direction? So how do I go from my X to my Y? You are multiplying each ticket is $9.50 per ticket, every ticket, and so on. So we're finding the relationship between those. You would graph the order pairs. You graph 1 to 9.5, or you can put 9.50. 2 would be 19 or 19.00. And then 3 would be 28.5 or $28.50 if you want to put a 0 there. Does not matter. Same concept. How much does it cost for 10 movie tickets? So 10 movie tickets would be on this side. I want to know the cost. Well, I showed you tricks with the zeros here. I have $9.50 times 10. That's, pretend you ignore the zeros here, right? This is 95 with 2 zeros. I move the decimal twice. 1, 2. Costs $95 for 10 tickets. That's true. That is what it would be. So it's $95 for 10 tickets. If you don't understand how I did that, I just basically ignored the zeros, put them back in, and then move the decimal 2 places. Now, of course, we have to do it. How many tickets can I buy if I had $50 to spend? Okay, so I only have $50 to spend. I want to go in the opposite direction. Well, you would do again the inverse operation. I am going to have used divide by 950. So I'm going to take $50 and I'm going to cut it into 9.5 or 9.50. I'm going to do it the way that most of you think about it. Okay, take my $50. Here's my decimal. And I got my 9.50. Oh, when the decimal's on the side, slide it. So I now have this huge number, 950 divided by 5,000. Or you can use common sense here, but you know, let's not go too crazy, I guess. All right. So I have to show you how to do this mentally, but let's do it this way. Okay. Doesn't work. Okay. How many 5,000s can I get, or how many 950s can I get 5,000? 950 times, let's say 9. Not going to work. Too many, right? What I tell you to always try? 5, right? Okay. That's 0, 25, 45, 46, 47. You got as much as I'm going to get. I'm going to get 5, and then I have a remainder, right? Well, because we're talking about full tickets, we're not going to be buying partial tickets. Whoops. Okay. So then I would have here, this would be 0, and this would be a 10, this would be a 9, 2, 1. I would have 5 point something. Well, can I buy 6 tickets? No, I can't buy 6 tickets. I can only buy 5 tickets for my $50. Because if I did 6 would not work. So in this case, how many tickets can I buy? I can buy up to 5 tickets. Now, one other way you can think about it this way. Okay, this is close to $10, right? And if I had 50 divided by 10, I'm going to be somewhere around 5 tickets. If I'm not sure, then I try 950 times 5, and then I go, oh, let me try 950 times 6. If I can go up to 6, great. If I can't, then I don't want to use it. Let me prove to you why I can't buy 6. This would be 0, this would be 30, this would be $54, and that'd be $57. So this is not going to work. This is another way to think about it. Kids said, well, can I keep on going until I can get a good answer? The answer to that is the most I can get? Absolutely. Guess and check works too. Okay, I don't know if I necessarily would do it this way. This is a little too much for me. I like it simple, straight to the point. Well, if I know 950 is close to 10, I know I should get somewhere around 5 tickets. 5 tickets is enough, but I can't buy 6, so I have to buy 5 full tickets in this case. Okay, all right, other kind of thing here. So I'm asking you to fill in the ratio table. So again, we're looking for the relationship between our input, our independent variable, and our output, our dependent variable. By the way, you should remember this from science, IV, dV. Okay? So I need to go, how am I going from here to here, here to here, here to here, here to here, here to here. Okay? So where do you have to start? You have to start out where you know some information. We know that money goes on top. I earned $91 for 7 hours. So remember, money goes on top. $91 for 7 hours. I want to know how much it costs for 1 hour. So what you would do is you would divide 91 and 7. So I'm making $13 an hour. So basically, how am I going from my input to my output? I am multiplying by 13. So from here to here is times 13. So I could do 2 times 13, which gives me 26. 1.5 times 13. So 13 times 1.5. 15, 6, 0, 31, 195, but with a decimal, so 19.5. Okay, and then the other one, we talked about this already, I'm going in the other direction. I need to use the inverse. So how many 13s make 65? 65 divided by 13. Well, I know 26 is 2, so let me try 4, 5. Let's try 5. 13 times 5. There it is. So this will give me 5. So my input is 5. That's why you have to go from your input to output. Look across. You can't, there is no pattern going down. There's no pattern at all. So that's why I tell you never necessarily to do that. But how do you solve these problems? First, you find, step 1, find the unit rate. And then step 2, then go with the pattern, forwards or the inverse backwards. Okay, very important to find the unit rate first, just like for this one. Okay, where do I have information to go from? Oh, I have a relationship between 9 and 225, gallons and miles. So miles per gallon, that makes sense, right? I wouldn't have gallons per miles, I'd have miles per gallon. So I want to know how many 225 miles in 9 gallons. I want to know how many miles are in 1 gallon. So again, I'm finding the unit rate. This is my X or Y, this is my X, and I'm figuring out how do I go from my input to my output. So whatever answer I get is what I'm multiplying by. Okay, so let's divide. 9 divided by 225 doesn't work. 9 times 2 is 18, or 45. 9 times 5 is 45. So I'm getting 25 miles per gallon. And that's okay, that's not too bad. So what I'm doing is I'm going from my X, I'm multiplying by 25 to get my Y. So 3/4, 3.25 right, is 75. 7/4, let's think about it that way. 4 is $1, so it'd be 100, plus another 3, so another one would be, so I have $4. I'm one short of $2, so I have $1.75. Hopefully that makes sense to you. If you not, you can do the side math on the side there. No problem there. But then I'm going backwards. I'm going to take the inverse. I'm going to divide by 25. How many quarters make $1? 4. Done. Again, I love 25, so I think about money. It worked really, really well for me. For me, it does. Okay. Again, find out what the pattern is by finding the unit rate, and then use that either you're going forward or your inverse going backwards, depending on the situation. Okay, this is called a double function table or double ratio table, technically as well. And this was like a type of error question that says, okay, basically we're going to fill in this table. So it's showing me hours, people are walking, looks like distance, Sam went, Logan went. Okay, we want to find the unit rate for Sam and the unit rate for Logan. That's where we got to start. So I need to figure out what's the relationship between 7 and 84, but also then the relationship between 7 and 56. Not between Logan and Sam, the hours and the distance, okay? So Sam is going 84 miles and it takes him 7 minutes. No, 7 hours. What's his rate? Now, hopefully you know. 12 times 7 is 84. So his rate is to multiply by 12 times 12. So from here to here will be times 12 times 12 times 12. Okay, I'm doing one step at a time. Just going to get Sam done. 1 times 12 is 12. 9 times 12 is 108. You know your 12s, it makes it easier. 12 times 12 is 144. I am now done with Sam. So how do I go from Sam's X to his Y? This is like the first Y, and you'll learn this. And this is your second Y, Y2, Y1 means the first Y, second Y. Same concept here. So his thing, order pairs would be 112. Then the next point would be 784. The next point I could graph is 9, 108. Next point I could graph is 12, 144. But I could figure out where 2's at. 2 would be at 24, 3 would be at 36, and so on. But again, make sure you see the relationship between the two. Now, ignore Sam now. We already finished him. So now pretend that this is like hiding. Don't look at it. How do I go from my 7 now to 56? Well, hopefully you know 7 times 8 is 56. So then for Logan's here, it is 56 miles in 7 minutes, or 7 hours, excuse me. He's going 8 miles in 1 hour. You go a little slower, right? A little slower rate. Go slower by 4 miles per hour. A little slower. But easy again. Ignore what I have here with Sam. So if I have Sam gone, and I can do this because I don't like the chaos. So now I need to go from my X to my Y too. So 1 times 8 is 8. 7 times 8 was 56. 9 times 8 is 72. And then 12 times 8 is 96. And there you go. So we had 12, 108, 144. I have now filled in my double function table. It's basically figuring out the relationship between X times 12 equals Y1. And then over here was X times 8 equals Y2. I just found 2 different equations for the 2 different people. They're rocking at different rates. One's going a little faster than the other. And if you notice, this is my Y over my X. My Y over my X. You look back real quick. You see how this was your y over your x? Your y over your x. Your y over your x. That's something you need to keep in mind in the future. Not going away. All right, last but not least, looking at now a graph and now figuring out what the unit rate is, okay? So remember, we always go from our x to our y. So what's my x talking about? Hours. Y is talking about money. Okay, so let's look at our ordered pairs. I have x is 2. When x is 2, y is 4. When x is 3, y is 6. When x is 4, 8, 5, 10, and hopefully you can see the pattern here. So where would my dot be at 1? That would be my unit rate. How am I going from my hours to my money? X times 2 is my y. So what's the unit rate? If I take $4, because money goes on top, right? Divided by 2 hours, I'm making $2 in 1 hour. That's the unit rate. Again, if you notice, the answer is the y over your x. What do we always say goes on top? Money. It's on my y-axis. Remember, this is your x and your y goes to the sky. Okay? All right, so we have a pattern of 2, multiplying by 2. Now, if I worked 4¼ hours, how much money did he make? So I'm at 4, I'm going to be between $8 and $10, right? Because 4 hours would be 8, $5 would be 10. So somewhere around there. So how much money did he make? Well, if I make $4.25, or $4 and, I'm sorry, 4 hours and 25 hundredths of an hour, and go to here, I'm going to multiply by 2. Or you can add it twice in your head, I guess. You get $8.50. So how much did he make? $8.50 in 2 hours. That's where it would, I'm sorry, that's wrong. $8.50 in 4.25 hours. That's a rate, not a unit rate. Unit rate was 2. Okay, going in here. Say I need to make $27 to buy a t-shirt. How many hours do I need to work? So I'm not working partial hours, I'm working full hours here. So in this case, you could use mental math. I need to get somewhere around $27 and I need to figure out how many hours I need to work. Now, if you want to be exact, you sure can divide and you have a decimal. But I would do the inverse. So if multiplying by 2 is how I go forwards, I do the inverse going back. Take 27 and cut it in half. We're going to be somewhere around, what? Somewhere around 12? 12 would be 24? No? Did I get 13? 26? Because 13 times 2 is 26. But is that going to give me to buy the shirt? I need to work 14 hours to get 28. So I need to work 14 hours to have enough. 13 is not going to cut it. 13 is not going to cut it. I need a little bit more to cover that cost. Be careful. Think about it. Okay. All right. Last one of these. One more of these just to kind of show you, make sure you're doing it correctly. Okay. We have on our x-axis hours. And our y-axis, we have miles. Okay, now let's graph our ordered pairs. 2 is 3. 4 is 6. 6 is 9. 8 is 12. And 10 is 15. Okay, now, what is the unit rate? We need to figure out how are we going from 2 to 3, 4 to 6, 6 to 9, this to this, this to this. So how am I going to my x my Y. So what do? We do miles per hour, right? Miles per hour. So miles, 3 miles in 2 hours. How far am I going in 1 hour? Well, if you know 3 divided by 2, you can do a mixed number, you can do a decimal. 3 is in the house, 2 is here, 1. Remainder 1, add a decimal, raise it up, add a 0. How about 1 1/2? Half of $3 is $1.50. There you go. It's $1.50 an hour, or $1.50 a mile per hour. You're going a mile and a half every hour. You can fly. Okay. It's a little crazy. Okay. Okay. Now, let's say I have a drone, and my battery life on my drone is 15 hours. Can it make to my friend's house that is 15 miles away? Or explain your work. So, my drone can go up to 15 hours. Other than that, it's going to die. It's going to fall to the ground. I need to make sure I can get to my friend's house that's 50 miles away. Am I going to have enough time to get there? So how could you do that? Well, you got to look at a couple different things, okay? If we have, let's look at the unit rate. If I can go 1.5 miles in 1 hour, I only have up to 15 hours to get there. How much is it going to take me to get there if I take up the whole time? When you multiply to see where we're going to get, where are we going to get to? Well, if you do 15 times 1.5, you have 25. 7, 0, 5, 1. It's 225. I should remember that one. And then move the decimal. I'm going to go 22.5 miles in 15 hours. Am I going to make it there? No. My drone's not going to make it there. So, no. The drone. Oh my God, I can't spell drone. Drone will only make it 22.5 miles in 15 hours. So therefore, it's not going to make it. We need another battery or tell your friend to get closer to you. Okay? It's not going to work. We don't have enough time to get there. So there you go. So you can think about it in the road. Okay? All right, go ahead and start your homework, and I will see you tomorrow.